Now the third type of structural isomerism is position isomerism. So what difference they are going to exhibit in this kind of isomerism? So obviously they are going to possess the same molecular formula, those compounds who are going to get the same molecular formula, then what will be the difference that they will show? They will actually differ in the position of the functional group, double, triple, single bond, double or triple bond, or they will differ in the position of the functional group, secondary functional group, that is any alcohol, aldehyde, carboxylic acid, or maybe differ in the position of the substituent. So see, look at the example. Suppose I'm just writing the formula, then you tell me that what is this compound actually, right? So what is the name for this compound? So what do you get to see? How many carbon atoms in a chain? 1, 2, 3, 4. So obviously it is but, single bond and all. So it is butanol, right? But when I change the position of this functional group, or if I move it to some other carbon atoms, see, I'm just moving it, then you tell me like what change it gets now. Now what is the name for this compound? Again, it has the carbon atoms, it possesses the 4, it also possesses the 4 carbon atoms. Here it possesses the 1 OH group, and here also it possesses the 1 OH group. But the difference is that this actually they differ in the properties now, because now it was earlier butanol, but now it has become 2-butanol, because at 2 position alcohol group is present. So likewise, it is just not, you can say the position of hydroxyl group is not changing, it is entirely changing its properties, right? Though the properties are not entirely changed, you cannot say that the properties get, you can say so it doesn't mean that the properties gets entirely changed. It means that though they both belong to the same family of alcohol, so they must be possessing somehow similar properties, but still they will differ in some properties, right? So this means they are actually the position isomers. Another example, suppose I have this. So what is the name given to this compound? You can see it has 4 carbon atoms and it has the double bond in it. So what is the name for it? It is butene. Now what I can do, I can make the isomer of it by just changing the position of double bond. So what I am going to do, I am just going to move the double bond from this carbon atom to any position which differ from this position. So suppose I am moving it to this position, right? So what is the name given to this compound now? Again, they possess the same molecular formula. 4C, 4 C's are present. Hydrogen 5, 6, 7, 8. Here also 3, 3, 6, 7 and 8. Again, C's are same, number of C's are same and number of H's are same. So that means the molecular formula is same, but still you can say they exhibit the difference in the properties, because now it has become but 2-ene. As the position of double bond is now changed, it has moved to the second position, right? So that means this is how we can say that these kind of compounds which have the same molecular formula but differ in the position of the functional group, or differ in the position of this thing, the double or single or triple bond, or they may differ in the position of alkyl group. I'll state an example for an alkyl group also. Suppose I have this compound, right? So what is the name given to this compound? This is attached, like if I count from this side it is 3rd carbon, again if I count from this side it becomes 3rd carbon, right? So what is the name for it? 3-methyl 1, 2, 3, 4, 5 pentane, right? So if I shift this position of this substituent, then obviously the properties are going to change. Yet the molecular formula will remain same, but still the properties are going to change. So I'm just moving this, I'm just changing this position. Suppose I'm moving it to this position, right? So now what is the number for this methyl group? Obviously we'll be counting from this side. So it will become 2. So it will become 2-methyl pentane. So they are actually in what we did in this, we just changed the position of the substituent. So they exhibit the position isomerism. So position isomerism is something in which the compounds are going to have the same molecular formula, but they are going to differ in the position of substituent, differ in the position of functional group, or might be the position of this double, triple and single, sorry not single, double and triple bond. So that means they can be changed in the primary suffix, they can be changed in the position of secondary suffix, and moreover there can be change in the position of prefix as well. So this is what is the